In the early months of the year 1601, harvests failed across regions that had no knowledge of one another. In parts of Europe, winter lingered long after it should have ended. In Russia, famine spread across entire provinces. In China, abnormal cold damaged crops and strained fragile food supplies. None of these societies could see the chain of events connecting their suffering. Yet thousands of kilometers away in the high Andes of southern Peru, a mountain had erupted with extraordinary force. The eruption of Huaynaputina in 1600 would trigger one of the most severe volcanic winters recorded in human history. Huaynaputina stood within the remote volcanic landscape of southern Peru, part of the Andean volcanic belt created by the slow collision of tectonic plates along the western edge of South America. For centuries the region had been shaped by volcanic activity, though Huaynaputina itself was not widely recognized as a major volcano before its eruption. It rose modestly compared to the towering stratovolcanoes surrounding it, and its slopes showed little obvious sign of imminent catastrophe. In the late 16th century, the surrounding region was part of the Viceroyalty of Peru, governed by the Spanish Empire. Spanish settlements, mining operations, and missionary communities were scattered through the Andes, while indigenous populations continued to inhabit valleys and highlands that had long been part of the Inca world. The area around Huaynaputina was sparsely populated but not empty. Farms, villages, and colonial estates existed within reach of the volcano. Early warnings may have appeared before the disaster, though historical accounts remain limited. Some reports from the time mention earthquakes and unusual disturbances in the ground during the weeks leading up to the eruption. In volcanic regions such activity can occur without leading to a major eruption, and people living nearby may not have recognized the scale of what was about to happen. On February 19, 1600, the situation changed abruptly. Huaynaputina erupted with explosive force. The eruption blasted enormous quantities of ash, gas, and rock into the atmosphere. Pyroclastic flows, fast-moving currents of hot gas and volcanic material, swept down the surrounding terrain, destroying everything in their path. Ash clouds rose high into the sky and spread across vast distances. Local devastation was immediate. Settlements near the volcano were buried beneath ash and debris. Agricultural fields were ruined, irrigation systems were damaged, and livestock died. Rivers became choked with volcanic sediment, and lahars, mudflows formed from volcanic material mixed with water, surged through valleys. Historical records from Spanish colonial authorities describe ash falling across large parts of southern Peru. Towns such as Arequipa, located more than 70 kilometers away, experienced darkness during the day as thick clouds of ash blocked sunlight. Roofs collapsed under the weight of accumulated ash, and drinking water became contaminated. The eruption continued in powerful phases for several days, with explosive activity sending ash and volcanic gases high into the atmosphere. Eventually the most violent activity subsided, but the consequences had only begun to unfold. The true global impact of Huaynaputina was not immediately visible. While local communities dealt with destruction and displacement, the eruption had injected massive quantities of sulfur dioxide and fine particles into the stratosphere. Once there, these particles formed sulfate aerosols that reflected incoming sunlight back into space. This process reduced the amount of solar radiation reaching the Earth's surface. The result was a measurable drop in global temperatures, a phenomenon known as a volcanic winter. Climate records reconstructed from tree rings and historical observations suggest that the years immediately following the eruption were among the coldest of the early modern period. The year 1601 in particular showed widespread evidence of abnormal cooling. In Europe, the growing season shortened dramatically. Contemporary chronicles from Switzerland, France, and parts of Germany reported unseasonable cold and persistent rain. Vineyards suffered, grain harvests were reduced, and food prices rose sharply in several regions. In parts of Scandinavia and the Baltic region, snow reportedly fell during months when it normally would not appear. Farmers struggled to bring crops to maturity before the arrival of early frosts. Russia experienced especially severe consequences. The years from 1601 to 1603 became known for one of the worst famines in Russian history. Grain harvests collapsed after repeated seasons of cold and wet weather. As food supplies dwindled, hunger spread through rural populations and eventually reached major cities. Historical estimates suggest that a significant portion of the population perished during the famine. The crisis also contributed to political instability during a period already marked by uncertainty following the end of the Rurik dynasty. The famine helped intensify social unrest that would later become part of the wider turmoil known as the Time of Troubles. Further east, evidence from Chinese historical records indicates unusual weather patterns as well. Cold conditions and crop failures were documented in several regions of the Ming Empire during the early 1600s. In agricultural societies heavily dependent on predictable growing seasons, even small climatic shifts could produce large consequences. Japan also recorded abnormal weather during these years. Diaries and local records described cooler conditions and poor harvests in certain areas. In the Americas, regions far from Peru experienced climatic disturbances as well. Parts of North America saw unusually cold winters during the early years of the 17th century. Tree ring studies confirm that 1601 stands out as one of the coldest years in the Northern Hemisphere during the last several centuries. The scale of the eruption helps explain these widespread effects. Modern geological research estimates that Huaynaputina expelled more than 30 cubic kilometers of volcanic material. It is considered the largest volcanic eruption in South America in recorded history. The height of the eruption column likely carried sulfur compounds high into the stratosphere, where atmospheric circulation distributed them around the globe. Once there, sulfate aerosols could remain suspended for years, gradually dispersing while continuing to reflect sunlight. For societies of the early 17th century, the connection between a distant volcanic eruption and global climate disruption was impossible to understand. Scientific knowledge of atmospheric processes did not yet exist, and most communities interpreted extreme weather through local or religious frameworks. In Europe, harsh weather and failed harvests were sometimes explained through divine judgment or natural cycles that were not yet understood. Similar interpretations appeared in other parts of the world. The eruption also had long-term effects in its immediate region. In southern Peru, vast areas surrounding the volcano remained covered in ash deposits. Agricultural recovery took years. Indigenous communities and colonial settlements faced displacement as farmland became temporarily unusable. Over time, volcanic ash can enrich soil by adding minerals that improve fertility. However, this process requires time and stable conditions. In the immediate aftermath of the eruption, ash layers disrupted irrigation systems and buried existing crops. Spanish colonial authorities attempted to respond to the damage through relief measures and resettlement efforts, though the remote location and scale of destruction made recovery difficult. Huaynaputina itself underwent dramatic physical changes. The eruption collapsed parts of the volcanic structure, leaving behind a large crater complex that still marks the site today. Unlike some volcanoes that erupt repeatedly over centuries, Huaynaputina has remained relatively quiet since the event of 1600. Modern volcanology has allowed scientists to reconstruct the eruption through field studies of ash layers, pumice deposits, and chemical signatures preserved in ice cores. Ice cores extracted from polar regions contain microscopic traces of volcanic sulfate from the eruption, providing evidence of its global atmospheric reach. Tree ring analysis has provided additional confirmation. Trees grow more slowly during cold years, producing narrower rings. Samples from multiple continents show a clear signal of reduced growth around 1601, consistent with a sudden drop in temperature. Together, these scientific tools have revealed how a remote Andean eruption produced consequences felt across the planet. The event also serves as a reminder of the interconnected nature of Earth's climate system. Even before the development of modern transportation or global communication, natural processes could link distant regions in unexpected ways. A volcanic eruption in South America could influence harvests in Europe, contribute to famine in Russia, and alter weather patterns across Asia and North America. The people experiencing these hardships had no way of tracing their origins to a single mountain thousands of kilometers away. Today, Huaynaputina is recognized as one of the most significant volcanic eruptions of the last millennium. Its climatic impact ranks alongside other major eruptions that have temporarily reshaped global temperatures. The eruption also illustrates how environmental shocks can interact with existing social and political vulnerabilities. In Russia, the famine of the early 1600s intensified instability during a fragile political transition. In agricultural societies elsewhere, even modest harvest failures strained food systems that had little margin for disruption. Natural events rarely act in isolation. Their consequences depend heavily on the resilience of the societies they affect. More than 4 centuries later, the ash layers of Huaynaputina remain preserved across the landscape of southern Peru. Scientists continue to study them to better understand volcanic processes and their influence on climate. These studies also help modern societies prepare for future eruptions. Large volcanic events remain capable of affecting global temperatures, aviation systems, and agricultural production. Huaynaputina stands as a powerful historical example of how a single geological event can ripple through the atmosphere and across continents. The people who endured the cold years that followed in 1601 had no knowledge of the Andean volcano that helped shape their fate. Yet the record left behind in chronicles, tree rings, ice cores, and volcanic deposits reveals the hidden connections that tied their experiences together. The eruption of Huaynaputina did not simply transform a remote corner of Peru. It briefly altered the climate of the entire planet, reminding us that the forces shaping human history are sometimes buried deep within the Earth itself.